Next, we're going to have Khalil giving us a bit of a different view of the varieties of
So I want to outline first. So I think that theories grow through three simultaneous activities. I really mean simultaneous, so it's not doing one before the others. So one is digging deeper to simplify first principles and the assumptions of the theory. Number two, to reach further, to control better, measure better, analyze better, and describe better. And the third is making sure that first principles and data that we're reaching for are like the two ends of a tight string, as close to each other as possible through the process of scientific prediction. Theory predicts this. This is what the data is, and you change both to make that string as tight as possible, and the data being as close to what we predict from first principles. And this is all easy to say, but it's actually, as we know, very, very difficult. So the talk is kind of about this spring of sorts, so the theoretical spring behind those two things together. And the talk is really more intended for students. This is the exciting thing for me about this workshop, is there are lots of students and people who recently graduated, etc. So I'm going to mention lots of things that I feel are going to be, innovations in the theory and that I hope people carry out. So I will start with what I think of as the core idea and difficulty of articulatory phonology, some of which is really good from Lewis. Then I'll talk about this variety of theories that have arisen and how they cohere together. And then further into complementary issues and maybe some hypotheses that are opposite to each other, which is also very good to have within theory. That's how theories grow. This release these dialectical forces. And then I'll talk about some of my own work on deepening first principles. And then I'll talk about articulatory phonology within this larger field of called linguistics, especially the study of phonology. So I came to test dynamics and articulatory phonology because I wanted to understand how formats move. And then that required me to understand how tongues move. And then I started to feel that this theory is a good theory of trying to do that. And then this is what I saw, the first sentence in the abstract of Salton and Montal. Abstract, discrete, context independent, is continuous, and it's basically, I've been there trying to understand the sentence for the last 20 plus years and really trying to appreciate it, really trying to not take it as a creed. I think people sometimes take this as a creed, life of life, creative of not that, all of these types of things. And it's just things that we say, this is what it is to be a person who practices what we're talking about. I think it's a lot deeper than this, and I think it covers everything that we do within the theory that is very much in the reach of the theory. So an easy theory would start by saying, we're going to do abstract things and not continuous things. Or continuous things and not, but this is easy. It's really easy because, and discursively, it's very easy. You can show lots of things that are good about one, not good about the other, and we go on and say, that it can be really easy to have context independent and not context, or the other way around. These are easy theories. That's what makes this theory very hard, or we're going to use symbolic logic or descendants of symbolic logic and not dynamic systems, or dynamic systems and not. And this is what I mean by core difficulty of understanding what this theory really says. It's to understand why it's really hard, how we combine those two and how we really resolve those difficulties. And the word reconcile is very good. So if hard, it's because the reconciliation contradictories is a very difficult task. So what I understood of the Pythagorean descendants is that speech is such a complex process in so many different levels that to make any sense of it, one would have to kind of be talking about everything at the same time, things that even seem opposite to each other. And gradually, within 20 years, I realized that's not the meaning of the sentence, and that actually this reconciliation is the beginning of all successful scientific inquiry. And I think that the really ingenious realizations of Carol Fowler, Gordon Goldstein, Elsewhere Hall, Salvador is the realization that the mathematical entities at the heart of all science, since Descartes and Galileo and Newton and Leibniz, which is differential equations / dynamical systems, are dialectical entities with abstract, discrete, context-independent constants, literally numbers that stay constant, and a graph that stays constant. So, like the first for the differential equation that Lewis talked about, and at the same time, a fast-changing, continuous, context-dependent flow. So these entities that describe the science and technology around us have these two things, and most importantly, a solution, what we call solution in mathematical physics, dynamic or a logic from which you infer flows from, so flows that are context dependent, continuous, from time invariant, context independent, abstract entities. So it's not as mysterious, and it's not, now it is extremely mysterious that things that are of the world describe things also in language. I think that is still, and it took ages and ages and ages for people to realize that there is this link. And for the details of how this is carried out, I would suggest that there are very nice definitions by a variety of people who try to explain what this notion of abstract, how abstract or and discrete is related to continuous, besides the original papers as well. So the way I see articulate phonology, from my perspective, so I changed the words a little bit to be the central words of motor logic. And it's a parametric motor logic because there are different graphs and different constants. And that's linguistic variation and the plurality of entities in language. You need parametrization, but nature is also parametrized in the sense that we have different equations to describe different phenomena that are closely related. And linguistic structure rides on top of this motor logic. The difficulty, again, is motor logic. Dualism, and I see dualism as how people describe alcoholism. You can't just say, I'm a pure, I'm no longer a dualist. It's something that just comes back again and again. And I have to revisit this issue and be like, no, I really want to do this again. And because it's a recurring, you can't get rid of it. And so motor is a rotation control body, whereas logic is the essence of mind, which is fundamentally non-physical. What I want to tell you is, and what gives me hope that this thing of articulate phonology is actually founded on well understood principles, is actually in the 20th century, beyond the 16th, 17th century of Descartes, we saw the deepening of logic itself, that thing that is supposed to be a time for all. And that has developed within the last 60, 70 years into temporal logics, spatial logics that cohere, from which you can prove theorems, etc. And these are called resource logics and linear logics, which are supersets of traditional Aristotelian logic. And indeed, the dynamical systems that Fowler, 1980, used to describe the implicit structure are named the same abstract plot as, for instance, Walensky has shown is the abstract plot from which cognition could be, and from which people in physics and mathematics have realized that there are these Rosetta Stones that tell us how things on the opposite side of mind-body dualism are mathematically equivalent. So just to give you the feel for what that means and why the notion of a motor logic is not as bizarre, not just because it works, because science works, but because of fundamental principles that we're starting to understand and refounding this and re-understanding the first principle for the theory like this and the possibility of the theory like this. So just to give you one of these Rosetta Stones, which are based on the work of many different people, and this it's just all connected. So things like dynamics, logic, grammar, and neural networks, things that, so when I was taught a little bit of cognitive science when I was in grad school, I was taught, well, there are these symbolic approaches, or there are these neural network approaches. I think a lot of expositions still start this way. However, the beauty of 20th century science and learning is that we see now the parallels and how there are the same mathematical structures that underlie many of these different columns together. So if you go down the column of dynamics, as described by Lewis earlier, you have these parameters that are constant, you have these state variables that change, you have a graph that stays constant. From these, you're able to logically infer a solution through a mathematical process that's pretty clear and well understood. And then you get a solution that's highly continuous, highly global, highly structured. And there are different qualitative behaviors of those solutions, like unit cycles, equilibria, and chaos. And what you get from looking at the by deriving a solution is things that are started out as uncorrelated become correlated and structured and modulated and coherent amongst each other. In logic, we have logical constants like and or and if, things like that play the same role as parameters in a dynamical system. We have propositions that have true or false or other things like probabilistic 0 to 1. We have what are called syllogisms or natural deduction rules from which you're able to derive propositions from earlier propositions. And then you have a proof argument system that allows you to derive further conclusions from earlier assumptions. And then you actually get the truth value of a final proposition. And what I have in this next to last column is the sense of the complexity of, so in dynamical systems, equilibrium is a very simple qualitative solution to the system, whereas chaos is the most complex. And within logic, we get referentiality and circularity as major issues that correspond, that Turing realized correspond to dynamic dynamics. On the side of grammar, those of you who studied about linguistics learned about finite state, context-free, etc. Stephen Wolfram showed the correspondence in the 80s between the different kinds of attractors of a dynamical system to the powers of different grammars, which are in mathematical linguistics, and these are correspond to each other very closely. Within neural networks, we have another set of, and these have been reduced by Bayes and other people into category theory, which is kind of a modern mathematical theory from which we express other mathematical theories. And there's something about this that underlies the possibility of a theory like And I want to add one more thing, which is why articulatory and why motor. So even if it is possible to have the notion of a logic and the notion of a dynamical system be part of the same theory, why this particular, and this arises because everyone's go out, I hear people, why don't you choose something different? And people still have some negative association. I think the reason I like articulatory and motor is just for articulatory is, in this sense, is that from the earliest stages of life, it's kind of what I studied, neural systems develop to allow animals to move and comprehend, perceive the environment around them, to be able to effectively act in it. And this is a long, long time ago. And neural dynamics, neural dynamical systems develop to allow animals to that have constants that are like neurotransmitter levels, graphs like network architecture, and flows like activations of neurons. So these are things inside of us that have developed across millions of years to allow us to be in the world and to function in the world. And the kind of logic we need for articulate phonology is just a logic that neural systems developed something like 700 million years ago, or probably a lot before that. And these neural systems were developed for locomotion, perception, and cognition. I think TAC is the sponsor for this meeting. Is it TAC? No. Oh, sorry. That's good, but that's what I've done. Yeah, so, and that's why we regard this logic as a motor logic, as a particular logic. And Linus, Nobel Prize winner in neuroscience, provides many explanations for why within those three things there is something about the motor side that is even more clear. Okay, now the reach, so the first major hypothesis within this particular development approach is that phonological contrast is a dynamical system with a fast phonetic variable, contrasted constant coefficients, and a second order dynamic developed over many years, but really started out with power, both with speed, and this is a really profound associating things of language with things of fundamental theories for describing nature. Then this is followed, another how, is that phonological alternation and syntactics / syllable structure are finding synchronization relations between interacting contrastive dynamic systems. And some of the same names and other names arise, and this is an additional hypothesis that lies on top of the first hypothesis. It's like, wow, and then like, wow, and then a third, wow. Because it's the notion that prosodic categories, like boundaries, and maybe more, are macroscopic spatiotemporal modulations of the contrastive dynamical systems that interact with each other. And these are this sort of, it's almost easy to imagine these once you see this one, but they're all, each of them is a fundamental hypothesis about phonological structure and how it works. And all of them are logics that are space-time logics. They depend on the idea of space and time in a very fundamental way, which makes them different from a lot of other theorizing in linguistics, but it doesn't make them any less logical and less systematic. Now, when you look at the context of this across centuries, phonologists, not thinking about language from a dynamical systems perspective, converge onto a bag of constructs to describe phonological systems of languages in the world. Things like context, segment, alternation, syllable, boundary. And then people like Selkirk, Vogel, and others postulated a hierarchy to put these things together, to organize these things together as part of, so there are things organized into higher level things, then higher level things, higher level. And amazingly, dynamical systems theorists, and I don't mean by that people in this room, I mean people who are in mathematics departments and physics and chemistry departments throughout the world, develop the dynamical systems of Newton and Leibniz and Euler and Lagrange. And what dynamical systems is today is a study of the following. Dynamical systems, these differential equations, how multiple dynamical systems interact with each other, because the evolution of one variable will depend on the evolution of other variables, and we call this reaction indiffusion, because reaction is the temporal, the slope of the rate of change of one variable will depend on the value of another variable, and maybe circularly so. That's what we call reaction. And diffusion is the value of one variable, depends on the variable, the values of spatially surrounding variables. So these are the interactions. And 20th century dynamical system is really study of modulation, more or less. The idea that interacting dynamical systems self-organize to create bigger things out of smaller things. That's 20th century. So those things qualitatively could be very different from each other, as like factors, limit cycles, chaotic structures, which are, by the way, extremely highly organized despite it being chaos. And a lot of modern physics is called Ginsburg, Landau, Wilson, for the 3 Nobel Prize winners throughout the 20th century that have organized physics itself with an understanding of modulation, or as they call it, renormalization, which is a study of physical hierarchy. And I find this really quite remarkable that these 2 things, and I think it's beyond one. I think the hypothesis that contrast is dynamical system drags in automatically, and with quotes on automatically, drags in the ideas of interaction and the possibilities of interaction and the possibility of modulation. So the constructs and hierarchy organizing them is potentially, I believe, predictable with modulation into scales. So I think that there is correspondence between these 2. That once the initial hypothesis was made, and I don't mean by that in any way to reduce the magnitudes of these 2 additional hypotheses, but it's to understand that they are actually part of a coherent whole that is potentially predictive. So it is potentially, if you allow dynamical systems to describe contrasts, that you are saying those things we call languages may have something like syllable structure. Those things called language may have something like boundaries. So these are not just accidents of history and just a bag of things that people have discovered about languages, that if you allow for the possibility of contrast, you're allowing for the possibilities of those other things, those hierarchical intelligence. I find that very, very exciting. And I just want to give you an example that many people have used before, really Bernard. So you have a pot of viscous fluid on a stove at low temperature. At low temperature, the bottom is hot and the top is cold. The high cold liquid wants to fall because it's heavy, and the low hot light liquid wants to rise. However, friction is high, so neither happen, and we have what we call a uniform fluid, really nothing happens. However, as we raise the temperature, gravity will overpower friction. And for some liquids, something really amazing happens. You have rolls, something's doing very well. Rolls develop so that in a highly organized way, the cold liquid falls and the hot liquid rises in a highly modulated, structured macro state. So the plot is this big. The molecules on which the forces act are very, very small spatial scales. However, they start to form 3-4 centimeter structures, and these are macroscopic structures that arise from, and all kinds of structures in the world have been shown to be these kinds of structures. So the world depends, for good or for bad, on the presence of these kinds of structures. These kinds of structures that are macroscopic arise from macroscopic interactions tend to have properties that we actually see in the kinds of things that we study, like whether you have these rolls going clockwise, anti-clockwise, or anti-clockwise, clockwise is completely arbitrary. Completely arbitrary. Those two things are completely equivalent. And I can think of all kinds of linguistic things like iambic versus propane as being very similar types of things. Language A may do this, language B may do this across the river. That's how language works as well. And I find that to be the other thing that I just want to say about this is that one of the reasons people bring up this example is something really profound, which is that at low temperature, when there is no variation in the system is born. It is at high temperature, when variation is maximal, that order arises. And I see that to be, so this is the only big in the talk against the idea of the universal grammar, which part of my understanding of that concept is once you remove variation, you get a figure that is describable. Here, it is under variation and noise that you get stuff. There's something really profound, because many people, including myself, believe that variation is at the essence of speech and of language, not something you need to get rid of. It's something, the order exists because of the noise. It's not despite it. And just, I like listening. So another example that I really like, this time from biology, are these octopus that can have stripes on them. They can also create things like leaves. And this is the neural system acting to take these sacks of color on their skin that are connected only locally and to create a global, organized, modulated pattern that I'm able to simulate using dynamical systems analysis with the action of diffusion of Turing. In this way, all the local interactions resolve into global modulation. The phase of the global modulation, whether the stripes are going to be right side up or diagonal, all of these things are completely accidental and and that's what I mean by modulation. So as I said, I think the contrast is a dynamical system drags in automatically all of these other things as possible. That's not the way things happen. People independently notice different aspects of our structure. And that's how these theories, so this dragging is not automatic, it's 20 to 30 years. However, the various theories of phonological structure, of phonological contracts, as they were proposed and developed over decades, are not as intrinsically related as the actual diffusion to action modulation dynamical system. And I think that is the major source of growth within this theory, is to realize how close these things are to each other and how they how these are not just separate hypotheses about phonological structure, these are intrinsically related and inferable from each other, while still parameterizable and allowing for cross-linguistic differences. And there are, I think, lots of questions that we can ask that people have been asking that can be formulated that are at the interface of these hypotheses. We think something like a liquid, and it has a very complex contrastive structure. Does that make liquids behave differently in Toda versus concept, which is a part of a different hypothesis? It pretty much looks like it does. And we can pursue this from a purely empirical point of view, but we can also pursue it from the depth of how liquid identity systems interact. And one, I think, fundamental conflict in phonology that I hope people work on is that one of the most attractive things about dynamic system approach, as I characterize it, is that it's non-dualistic. The same differential equation has dependent and independent variables that will change as life will scale, and parameters that are constant, or basically constant. This is the problem of autonomy and has seemed to be fundamental as it's at the heart of the transcendence of dualism. However, the predictions. So, for very good reason, various people, for very good reason, propose time variation in the parameters, since it's important for the theory to actually. However, more recently, Sorensen and Gaffos have shown that it's actually possible to maintain the original hypothesis, so change the second order linear dynamical system to a fluid nonlinear. However, things are actually not that clear, even though I side with one of these, siders. Solo linear has been looked at, especially data that extends over significant enough portion of time to even test these ideas. So this is a really important debate because it's a very part of what it is to be a non-holistic system. And I invite people to work on this problem so that we understand the social economy and whether we actually have autonomy or whether we don't have autonomy, or maybe autonomy is just a different level, which is another approach to all of this. Another fundamental conflict is mechanics and phonology. So we didn't impede the initial hypothesis was that what is phonologically relevant in speech production are the contrastive tests. Articulatory is just do what they're told by the phonology. However, many have observed that mechanical differences in contrasts affect higher level planning. The idea is that spatial mechanical differences between clusters affect the timing and interaction of those segments. So, for instance, Mariana and Jag and myself have, from very different angles, have grappled with these issues. But the degree to which there are opposing hypotheses regarding this matter is not at all clear because no one has stated these opposing hypotheses, but they exist. So that's another problem that I think we need to understand because it matters to the development of the issue. So, as I mentioned, I studied the behavior of 1 millimeter CLDX worms, and scale of octopus, as well as problems with the MRI to dig deep into motor logic. So, you see what I mean by motor logic. This is going to be the octopus logic exists in the normal system on its skin of local interaction between global modulated pattern. And I believe that by studying these systems, we are studying the issues of, and the last common ancestor between these three animals is like 7 years ago, it's like motor logic is so on. Another thing that I do, work with Marie, is templates. Templates, templates in development, ML templates in the Protein Principle study, I think these are one of the major sources of evidence about desired structure and about segmental interaction. I think one of the problems in articulatory phonology is Lewis made an observation a long time ago about the centrality of the CD syllable. And that's a really important thing. But there are many other observations that have been made by phonologists over 50 years. And through the kind of social separation between phonology and the rest of the traditional phonology, we've lost a lot of the data that can tell us an enormous amount about things that we call causality. Not everyone, some people pay attention to these things, but I think they're more. And it's the only hint for me as to what a word is in articulatory phonology. Because a word could just be addressed about something. And then I'm really interested in acoustics, and I think that we're never going to get anywhere with this model line if you don't understand how it functions. So I pay a lot of attention to this. And inspired by Doug, I also work on documentation and revitalization of languages, because without languages, there isn't going to be, this work is always going to be. And as you can tell me much better than I, languages are incredibly growing away. And a lot of the evidence on these templates, most of the work on templates that we know from the participants is on Australian languages that are applying with English. And one last thing is something that most people don't hear about. No, that's something people don't. Well, how many people? Yeah, 5 minutes. Really good. Okay. Then I'll tell you about something that people don't. So, identity phonology and ophthalmology. So, the most common theory of phonology has been ophthalmology theory for the last 25 years. There are universal phonological constraints, but they're ranked, treated differently in different languages, and that's possibility diversity. And there have been several attitudes relating to phonology and ophthalmology theory. One is that articulatory phonology provides many marked constraints of ophthalmology theory. That is AP's kind of part of the representational articulatory. The other more prevalent is theories are just competitors, but metrics are still different, so little use comparing, and if you just look on what this is going to go away. If you read this paragraph from going in 2000, this is a paragraph immediately after. This is about the competition within the onset, between the onset consonants and the vowel. This is implicit. It's all about constraints, the competition between constraints, the resolution of the competition between constraints, but it's entirely explicit. I think that a lot of work on cross-linguistic variation from the AP perspective, like why the system will sometimes work, why they not, sometimes further, etc., that a lot of cross-linguistic variation is in this notion of waving and writing, which is not as distinct. This is the Leibniz, we do the Newton. So Newtonian dynamics is what we use, and Smolensky's logic, OT is just Leibnizian logic of dynamics. So the things are not as distinct, and we may very well be helped by looking at how people have thought about computation in terms of ranking and in terms of weighting in a very deep way. And a lot of the, I think, work in cross-linguistic variation from an articulatory perspective to benefit you from the same.
Okay, so thanks. We're going to move on to the next talk.